All right, 311. Equations, repeating decimals, all that good stuff. So, positive side, there's really only one thing to do, and it is to turn all these repeating decimals into fractions. That's what we're up to here. But there's two different types of repeating decimals going on here. And we'll have to talk about each one of them, how this is going to work. But the two types of scenarios, and the first thing you're always going to want to do when you have to do these types of things, is you need to know, first thing you have to ask is, do the numbers all repeat like this, 090909, 11111, or do they not? Like this one is 0.8777777. The 8's not repeating. So depending if the numbers all repeat or if they don't all repeat, changes up how we have to approach the problem a bit. Okay? So we're going to talk about it in two parts. So I guess I already have a piece of paper. We're going to start with a simple one here. I'm just going to make one up. 0.7 repeating. And again, our goal is to write this as a simplified fraction. All right, simplified fraction. So what we're doing here is go back to rational, irrational numbers type stuff. And we always said that the main test is that it can be written as a fraction. If you can write it as a fraction, it's a rational number. If you can't, it's not. But we've also always said that repeating decimals and terminating decimals are rational. Non-repeating, non-terminating are irrational. But repeating decimals are rational, which means I can write them as a fraction. For example, we probably know this one right here, 0.3 repeating. What's that? It's 1/3. Right? 1/3. 1 divided by 3. There it is. It's 1/3. You know, if I wrote 0.3, what's that? That's 3/10. Right? They're very different numbers. One of them is 0.3 repeating, the other is just 0.3. And they both have different values. So our real challenge is to figure out, if I know this, how can I get it to that? Now 1/3, kind of an easy one, but a lot of these here, as you can probably guess, well, we have no idea what it's going to be right at the moment here. So, how do I want to call this here? What's the book call it? We don't call it anything. So let's call it this. 1. Repeating decimals where all the values are repeated. As I said, we got two different things. One if they're all repeating and one if some are repeating. So we're going to start with this one here. Okay. So here's what you got to do. 0.7 repeating. And there's a number of steps here in these process, so it's going to take some time. So first, write the equation x equals the repeating decimal. So all I need to do here in my first step is write x equals, or whatever variable you want. If you want something other than x, use something else. 0.7 repeating. That's the first step. So we're writing it as an equation. Basically, you need to get an equal sign in there. You need to get a variable in there because we're going to be solving for something here. All right, that's the first. Whatever it is, just write it out as an equation like that. Okay, 2. Multiply both sides of the equation by 10 to the nth power. What does n mean? Where n is number of digits that repeat. So keep this equation, but we're going to be basically making a second equation now. So here was my first equation. All right, and I would rewrite it. Now, how many decimal spots are repeating? One. Just this. There's only one number that's 7. So you just said n is 1. So I would multiply everything. Basically, we want to move the decimal all the way to the right of the repeating. So I would multiply everything here by 10. And I'm going to get a new equation now. What's 10 times x? 10x. And then 0.7 repeating times 10 is, so I got 10x equals 7.7 with just that. Again, I'm just putting that over there. All I did was multiply by 10. So this is my second equation. First equation's up here. And this matters. You're going to find out why. Here's my first equation, where I just write it out, x equals whatever. All right, the second equation, right here, is where I figure out, do I multiply by 10, 100, 1,000? Depends how many decimals are repeating here. But that's my second equation right there. I have two equations I have made. Agreed? Equation 1, x equals whatever. Question 2, well, how many repeating decimals are there? 1. 10 to the first power, well, that's just the number 10. So multiply everything by 10. 10 times x, 10x, and just slide the decimal basically one spot. The 7's still repeating. Okay? 3. Subtract the original equation from the new equivalent equation that we made. So to do step 3, we need the two equations. So basically I take my new equation here, which was 10x equals 7.7 with the 7 repeating, right? Now I subtract my first equation, which was x equals 0.7 repeating. So here was my very first equation, right? There it is, x equals, and then here was my second equation when I multiplied by everything by 10. My two equations are right here. And now I'm going to subtract them. Take the new one, it's always going to be bigger, and subtract the first one from it. So what's 10x minus 1x? 9x. And now 7.7 repeating minus 0.7. Basically these just cancel itself out, and all I'm left with here is just 7. Because anything subtracted from itself is 0, right? 0.7 repeating minus 0.7 repeating is nothing. It's gone. You agree with that? So now, this is my final equation. Right here. After I've subtracted the 2, and then finally, to finish it, solve for x. The solution is the fraction equivalent of the decimal. So just write our equation down one more time where we were. There it was there, where we finished up there. So how would I finish this equation? What do I need to do? Huh? What the hell is that sound? Hopefully it doesn't keep getting louder. Right, divide each side by what? 9. So this cancels out, and what am I left with? There's my answer. And these are very easy to check because we already know where we started, right? This 0.7 repeating number, right? So all I do to check it is take the top number, divide by the number. And again, this is an 8 here. It's not really an 8. Our calculators, what they do is, again, they're limited by their screen size. So again, you should be able to realize this goes on, but it rounded this last spot here. It just kind of ends it here, but there is no 8 really here. It's just it rounded it to that. So this is 0.7 repeating. And that's what it is. That's where I started, 7/9. When I work through all this, subtract this and that, and da-da-da-da, there it is right there, 7/9. So let's look at number 2, or not 2, not 3. Where's a good one here? Let's look at number 9. We're going to try it. Let's see what happens to us here. So we'll walk through this together. Okay, this is number 9, 0.261 repeating. So I want to turn that into a decimal. Okay. So again, I got my 4 steps here. And if I go through them all, just one at a time, take my time, this should work out. So the first thing says, write an equation where x equals the repeating decimal, step 1. So x would equal so there's step 1 right there. Just write out the equation where x equals whatever it is. Okay? Second, now we need to multiply both sides of the equation by 10 to the n, where n is the number of digits that repeat. How many digits repeat? 3. 2, 6, 1. 2, 6, 1. 2, 6, 1. 2, 6, 1. 3 digits repeat. So that would be, and you said third, 10 to the third is 1,000. So that's telling me that I need to multiply this thing by 1,000 on both sides. So if I go 1,000 over here, 1,000 over here, and my second equation would be 1,000x equals 261.261 repeating. Step 2, make that second equation. Figure out how many repeating decimals you have. We got 3. If you got 1 repeating, multiply by 10. You got 2, multiply by 100. You got 3, multiply by 1,000. We won't go any higher than that. So, okay. Now, take my new equation, this 1,000x, and subtract my first equation. So when I subtract, I get 1,000 minus, and you can write 1x, so now I have 999x equals 261. So see how I did that, where these came from and how this worked. Again, we're trying, what you're ultimately trying to do is get rid of this repeating thing. That has to get out of here, but it takes a little work to remove it. It takes all this work to remove it, but when I've done it, these again cancel out. And finally here at this point here, I don't have that repeating decimal around anymore. So then finally, solve the equation here. You would divide both sides by 999. But we have to simplify. And you may not know all the things, but you should be able to conclude this divides by 3. So 261 divided by 3 is 87. 999 divided by 3 is 333. And looking at that, I see it divides by 3 again. So, or I could have divided by 9 in the first place. 29 over 111. So I divided by 3, and I got to there, then I divided by 3 again. And if I check it, go into my calculator, 29 divided by 111, there it is, 261, 261, 261 repeating. Right? That's it. So easy to check. 29 divided by 111. If I don't get 0.261 repeating, well, then something's wrong. I did something wrong. So these are arguably the easiest answers of all time to check. Unfortunately, getting the right answer can be a challenge sometimes. So, and then right here was step 4, right here, where I just solved the equation. Simplify your fraction. Always simplify fractions there. Step 1, step 2, step 3, step 4. Cord, if you want any of this stuff, you can have it too, by the way. So, especially this one for your notes or whatever there.
Thank you.
So, right. Oh, let's give you guys another one here. Let's see what you can do with this one here. I'll try those a little bit. Let's do one on this page. Well, you sure don't have a lot of good ones here. I'll just make one up. How's that? 0.37 repeating. So what is that as a decimal? I'm going to let you guys go. I'll work it. Let's see what you can do. Same model we used for the first two will serve you well here. 4 steps. All right, so first, step 1, write out an equation where x just equals whatever I got. There we go. Second, figure out how many repeating decimals there are. There are 2. And multiply by that, of course, 10 to the second is 100. So multiply everything by 100. And I should get 100x equals 37.37 repeating when I multiply by 100. So then subtract 100 minus 1 is 99. X equals 37. And divide both sides by 99. That is a prime number. So I think 37 over 99 most likely is what we got. 37 divided by 99 is 37, blah, 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 blah. So step 1, write the equation. Step 2, figure out what I need to multiply to get that second equation. Now I have 2 equations. I can go to step 3, subtract them. And finally, step 4, just divide and simplify if necessary. How'd that go? Okay? Well, let's shift gears again. All right, here we go. So the other part. we'll call this renaming, repeating decimals that have digits that do not begin repeating immediately. Kind of a long title here. So we'll create one up here. Let's go with 0.024, which is the 4 repeating. Okay, so this is a little more complicated here. Okay, a little more complicated, but we have a shot. Okay, first, write the equation x equals repeating decimal. Same thing we did to start the other one. All right, all same thing there. Okay. 2. Multiply both sides by a power of 10 to move the decimal. Point immediately to the left of the repeating digit. I'll let you write that here. Multiply both sides by a power of 10 to move the decimal point immediately to the left of the repeating digit. So I'm going to write out my equation again here. Okay, let's carefully consider what we need to do here. Multiply both sides by a power of 10, okay, to move the decimal point immediately to the left of the repeating digit. Where is my repeating digit? What is it? 4. And it's saying I want to get my decimal immediately to the left of it. Right here is where I want it to go. To the left, not the right. So that means I'm multiplying by what?
10.
Here's my decimal, and I want it to be over here. How many spots does it have to move?
2.
Which means I multiply by,
10 to 2.
which is,
Negative. Negative 2.
if I move it one spot, that's 10. 2 spots, 100. 3 spots, 1,000. Right? So I'm moving it how many spots?
2.
Which means I'm multiplying by
100.
100. So I multiply everything by 100. All right? And now I have 100x equals 2.4 with the 4 repeating. Agreed? 3. Multiply the new. Okay. We are done with this equation here, by the way. All right, we're not going to use it again. We're still going to use 2 of them, but this is the first equation now. All right, this is equation 1. This is just to get to equation 1. All right, so there's my new equation. Multiply the new equation, same thing, by 10 to the d, where d is the number of things that repeat. Or what did I use n before? Or did I use n? Let's call it n. no need to, n equals the number of digits that repeat. So here is my equation. And the question is, how many repeating digits do I have? 1, just the 4. So if I have 1 repeating digit, n equals 1, what am I multiplying both sides by here?
10.
10. So now I multiply this thing by 10. So now I have 1000x equals 24.4 with the 4 repeating. Okay. And now to finish it, it's going to be the same. Okay. I'll give this all to you, Cord, in just a minute. 4. Subtract the simplified equation from step 2 from the simplified equation from step 3. Subtract the simplified equation from step 2. So when I say the simplified equation, this is the one I want right here. That's my step 2 equation. And this, my step 3 equation that I solved. So basically I got 1000x equals 24.4 repeating. And then I'm subtracting this one. 100x equals 2.4 repeating. And then again, the repeats are going to cancel each other out. So 1000 minus 100 is 900. And then this more or less just cancels out. 24 minus 2 is 22. And then 5. Solve for x. So there it is. 900x equals 22. Divide both sides by 900. That's gone. X equals 22 over 900. That could be simplified. Divide both of them by 2. 22 divided by 2 is 11. 900 divided by 2 is 450. X equals 11 over 450. And if it's truly right, I should get that. 11 divided by 450. And there it is, 0.02 with just the 4 repeating. As it is. With just the 4 repeating, not the 0 and the 2 though. And the 4 repeats. So it's 11 over 450. Okay? All right. Let's try one here. Let's try number 5. We'll make it positive. So 0.16 with just the 6 repeating. I'll give you a moment and then we'll do another one then. So 5-step process here. So I'm gonna go through it. We'll do a couple more. So first, step one, just write out the equation like I did for the other one too, where x is just gonna equal whatever. Here's step one. All right. Step two, I need to move the decimal so it's right to the left of wherever the repeating digits happen to begin. In this case, I gotta move it one spot. Gotta go from here to here. So since I'm only moving one spot, that means I'm multiplying by 10. 10 times x is 10x. And then this is 1.6 with the 6 repeating. Step 2. Multiplied everything by 10 to get the decimal, so it's right to the left of wherever the repeating starts. All right. Step 3, figure out how many repeating decimals there are. There's 1. And then multiply by 10 to that power. So once again, I'm going to be multiplying by 10 again. So 10 times 10 gives me 100. And over here, now I have 16. Multiply by 10 again. So I multiplied by 10, and then I multiplied by 10 again. So now I have my two equations. At this point, this thing is done. We have no more use for this equation. It's these two equations I want. So now, step 4, take the equations and subtract. 100 minus 10 is 90. These cancel out. 16 minus 1 is 15. Step 4, subtracting the two equations from each other here. And then step 5 is just turning it into divide both sides by 90. So 15 over 90, that could be simplified. Divide everything by 5. 15 divided by 5 is 3. 90 divided by 5 is 18. And then 3, 1/6. So I just divided by 3 here. And then, I divided by 5 here. That's what I did, not by 3. And then I divided by 3 here. 0.16 with just the 6 repeating. 1 divided by 6. 0.16 with just the 6 repeating. Yeah, that's good. 1/6, step 5, right there. These. Okay, now I'll give you guys one. See what you can do with it. Try number. These are all terrible, to be honest with you. I think they do better with us. I'll just make one up. 0.315 with the 1 and the 5 repeating. Try that. 0.315 with the 1 and the 5 repeating. Give you a moment here. So 5 steps. First, step 1, just write out x equals whatever I got. Step 1. Step 2, I need to move that decimal so it's just to the left of wherever the repeating is going to begin, which means I need to move it 1 spot to get it to the left of that 1 is the first digit, so I need to move it 1 spot, which means I'm going to have to multiply by 10 to move it 1 spot. So then my second, multiply everything by 10, 10 times x, and then slide it 3. Step 2, just getting the decimal right to the left of wherever it repeats. Step 3, I need to figure out how many repeating decimals I have. Looks like 2, the 1, 5, 1, 5, 1, 5, 2 repeating decimals. So 1 repeating decimal by 10, 2 repeating decimals by 100. So now I need to multiply this by 100. So 100 times 10 is 1000x. And this would be 315 with the 1, 5 repeating. Multiply it by 1000. Multiply by 10 to the n, where n is the number of repeating decimals. 2. 10 to the second power is 100. So now I got my 2 equations. I can subtract. So 1000 minus 10 is 990. These cancel out. 315 minus 3 is 312. Subtract the equation from step 2 from the equation we made in step 3. That's what we do in step 4. And then finally, now we can finish this off. Divide both sides by 990. Again, I wouldn't profess to know all the factors of these numbers, nor do I really care. 312 divided by 2 is 156. 990 divided by 2 is 495. 612, both of these divide by 3. 156 divided by 3 is 52. 495 divided by 3 is 165. That's as far as that's not getting simplified any farther. 52 over 165. Check it. 52 divided by 165.315, which is the 1, 5 repeating. Yeah, I just wanted to see. So there it kind of is there, step by step. We'll do another one of these. Well, let's shift over. We're going to practice. You feeling somewhat okay with this? I'm going to tell you the homework. I want you to do every 4th problem today. These take a while. So you're only going to have 6 problems on the homework. If you want to practice more or do some more, I can do some with you, but I don't want you to get brutalized by the homework. So every 4th problem, 4, 8, 12, 16, 20, and 24. There's your homework. 6 problems. They'll all take time, though, and quite a bit of work, so it's too many problems to do. So if you want to do some others to practice, or we can practice some of the others, that's totally cool here, but I just don't want to brutalize you guys on homework here. It's tough, right? Okay, let's look at another one here. Okay, let's look at one on the back. In the back here, it's more or less the same thing. More place values to an extent. Some of them have whole numbers now in there too. So let's try 17. Now the same rules are going to apply here. Just because we're starting with a non-zero number doesn't change anything. But what should happen is when you're representing your final answer, it should be 8 and something. You should have a mixed number answer here for this one, right? Because it's 8 and 0.634 with the 3-4 repeating. So whatever your answer is going to be, it's going to be 8 and some sort of fraction. Because again, that's right. So we can use the same rules here. So first, x equals there's my first equation. Now, you need to get that decimal one spot to the left of the repeating decimal, so what do I need to multiply by? 10, because I want to move it one spot, right? Agreed? So multiplying by 10 is the key here, to move it that one spot. So now I got 10x equals 86, and the 3-4 repeating. What do you need to multiply by next? For your next equation?
1,000.
Not 1,000. Step 3, how many repeating digits do you have?
2, so 100.
Right. So multiply this equation by 100. You'll end up with 1,000x equals something, but that's because you did 100 times 10 to get there. Right. So now multiply by 100. What's your new equation? And then subtract this equation from that, simplify, and bring it home. See why I wanted to start a little earlier today. Yes, and I'm happy we did. Multiply by 100, I should get 1,000x equals 8,634 with the 3-4 repeating. So now I got my two equations here. Subtract. So subtract 10x equals 86.34 repeating. 1,000 minus 10 is 990. I just don't, my brain is tired. Minus 86 equals 8,548. Yep, 8,634 minus 86 is 8,548. So subtracting the equations. Then divide both sides by 990. And we already know it's going to be 8 and something. So I could do this a few different ways here. 8,548 divided by 8. That's not helping us a whole lot there. Or 8,548 divided by 990, I should say, because it says 8 point blah, 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 blah. And again, we know we got the right answer at this point here, but this is far from simplified. It's an imperfect fraction. There's nothing, it needs to turn into a mixed number. I mean, mathematically, though, I just tested it, and we're cool. The answer's good. No problem there. But this is not how we would represent a fraction at all. So I already know it's 8. I can do 990 times 8 gives me 7,920. So I can take that and go 8,548 minus 7,920 gives me 8 and 628 over 990. So what I did is I already knew it was 8. So I just did 8 times 990, because that's my bottom there. 8 times 990, and then I got this 7,920. So 7,920 over 990 equals 8. Right? So, but of course I have all sorts of stuff left there. So now I need to subtract that 8,548 minus 7,920. This is the same, one and the same. We've done this concept many times before, just never with these types of numbers though. But easy to verify, of course, you just go 990 times 8, boom, add the numerator, plus 628, boom, boom, right, they are equivalent. You just multiply these two, add that, and it should equal that, right? Just like any other 3 1/3, 3 times 3 is 10 plus 1, 10/3, they are one and the same, right? Well, 8,548 over 990 is the same as 8 at 628. So, of course, again, time to simplify. I don't know everything that divides into all this stuff, but I know it divides by 2. 314 over 495. I don't know, is that it? I hope so. Yep. There's my final answer right there. Okay. Well, Cord 150. Nick, you want to do one more? Good? All right, Cord, you're off and away.